Chapter 16 has to do with electric forces and fields. So static electricity, a form of electrical energy that deals with the buildup of electric charge on an object, and the sudden transfer. Now, this is something that you felt in everyday life, like you walk on a carpet and you touch something and you get a shock. That's static electricity. But in order to fully understand static electricity, we have to actually understand the atom, because static electricity is the flow of electrons. And after the lesson's over, we're going to talk about and kind of figure out why it's the flow of electrons. So static electricity is the flow of electrons. So when we go back and look at an atom and look at the subatomic structure of an atom, we see that an atom contains 3 subatomic particles, the main particles. We see that we have a nucleus, which is in the middle. Now, the nucleus is where most of the mass of the atom is concentrated. And there we have protons, which we call positive, and then we have neutrons that are neutral. Then on the outside part, in what we call the cloud, we have electrons that are negatively charged. Now, when we talk about electricity, we need to know, and we're going to have to know this for a lot of our homework problems, what the charge is on these subatomic particles. And again, for those of you who took chemistry, which is most of you, this should be a review. So the charge of an electron is negative 1.6 times 10 to the negative 19 coulombs. A proton is positive 1.6 times 10 to the 19 coulombs. So you see that this is very minute, and that their charges would then balance each other out. So we're going to talk about objects being neutral and stuff like that. So the overall charge of a normal atom is neutral because the number of protons is equal to the number of electrons. But that's not always the case. If an object gains electrons, the excess of electrons give the object a negative charge. So what does that mean? Well, we have to conceptualize that. So let's say I have an object, and here's the object, and the object has the same number of protons and electrons. So the overall charge on the object is neutral. But now it says if the object gains electrons. So now it's going to get some extra electrons, because the electrons are the only thing that can move. So now when it gains electrons, the overall charge is negative. So sometimes that when you try to memorize things in words, sometimes it can be confusing, because it's when you think gain, you think more. So when it gains electrons, the overall charge is negative. Okay? And then if an object loses electrons, so if I have my same object, and now it loses an electron, the overall charge is going to be positive. Okay? So there's 3 ways that an object will acquire a charge. So friction, when we rub something, and we did that at the end of the last lab that we did. We used the 3 different rods, and we rubbed them with silk, with wool, and with fur. And we saw that we were able to transfer electrons from one object to another, and then we were able to make an object have an overall charge that was positive or negative. So then then we compared it to the bubble. So we're going to be doing more experiments like that. So again, friction, when one object rubs across another, what happens is we actually transfer the electrons. So when one loses electrons, the other one gains electrons. So here's a couple of important terms we need to know. So conduction, when a charged object is touched. So the key word here, and we have to look at this, is touched. So for conduction, the key word here is touch. You're actually touching the other object. Now we're going to use an instrument called an electroscope, which demonstrates static electricity. So there's going to be a knob, and again, it's very key when you're reading something or looking at it, saying, is it being close to it, or is it actually touching it? So conduction has to do with touching. So when a charged object is touched to another object, it causes a transfer of charge between the objects. And then they each acquire the same type and amount of charge. Induction is when a charged object is held near. So you see how this one is not touching? So this is different. So when you bring it near, what's going to happen is it's going to change the arrangement of the charge, but then when you take it away, we're going to see what happens. So it's going to be a little bit different. So the rules for electric charges are like charges repel one another. So what do I mean by like? Like would be positive and positive and negative and negative. So these repel one another. And then unlike charges attract one another. So that would be positive and negative because that's unlike. They're different. So a free electron are electrons in a metal that are not tightly held by the atom. So these are the ones that are able to move. A conductor is a material that allows electricity to flow through it easily. So conductors, and there's different, all conductors vary. So basically in layman's term, a conductor means that it's a good, we're going to learn, it's a good conductor of electricity, but that means the electrons can flow through it. So copper is a very good conductor. Most metals are conductors. And conductors actually, like metals, they're good conductors at room temperature, but as we heat them, they actually lose their conductivity. And then we have other materials that, let's say at room temperature aren't necessarily good conductors, but then at high temperatures, they're good conductors. So when a negatively charged object, so negatively charged means it has a lot of electrons on it, is brought near a conductor, free electrons are repelled. So an insulator is a material that hinders the flow of electricity through it. So examples of that are glass, rubber, and plastic. So if you've ever looked at any tools that you have at home, whether it be a screwdriver, a hammer, a saw, anything, every tool, most of the time a tool is made out of metal. But the handle, the part you're touching, is made of an insulator. And why does that tool have an insulator on the end? Because if you accidentally are using the tool and you touch electricity, you don't want to get an electrical shock or get electrocuted. So they put insulators on the end. Now, a long time ago, I know when I saw my grandfather's tools, his tools all had like wood handles. Now they make, but the problem with wood handles is they can get wet, they can get ruined, you can get a splinter. So now just about all tools have like plastic or rubber handles. So the earth is a great conductor, and it can accept or donate large charges. So what happens is, even though we say the earth is neutral, if we want to neutralize something, we call it grounding. Now this is just to kind of show you. Let's say I had a wire. With an insulator, we have very few electrons available to produce a current. Current is the flow of electricity. So we have electrons that move. So electrons moving, that is current. And then with a conductor, many are available to produce a current. Now when I charge an object, let's say like we did the lab the other day and we rubbed one of the materials on the rods and then we had an excess of electrons. When we take that negatively charged rod and we bring it to a neutral object, what happens is we can, the excess electrons are going to actually repel the electrons in the object. So it's going to cause the actual object to redistribute the charges within it. And we're going to do a lab next week where we'll see all of this. So this, again, is called induction. So these are just kind of pictures of some of the definitions we just talked about, and then we're going to see it firsthand when we do the lab next week. So here's another one. If the rod, so I have a negatively touched. So remember, this one is not touching. Induction is where it's brought near. So then conduction is, remember, where I'm going to touch it. So again, it's important to understand the difference between induction and conduction, either touching or being brought near. So now when I bring it near, I'm actually going to transfer those. And then they'll end up having the same overall charge. Now this tool that we're going to be using to study electricity is called an electroscope. And again, it's a device used to study static electricity. So we know that the smallest electric charge that can exist, again, 1.6 times 10 to the negative 19 coulombs. So if it's a proton, it's positive. If it's an electron, it's negative. So grounding, the removal of static electricity by conduction. So if we're doing a lab and you're doing the electroscope and you transfer electrons to the knob and now the overall charge on the electroscope is negative, if you just want to neutralize it and get it back to neutral, you just take your hand and put your hand on it and it neutralizes it. So a neutral object, again, has the same number of protons and electrons. When a neutral object gains electrons, it gains a negative charge, and when a neutral object loses electrons, it has a positive charge. So again, here's again a picture. I have a glass rod. It becomes positively charged when it's rubbed with silk. Now, if you remember before, we had the 3 rods and we had the 3 materials. So we're going to, again, be using these in our lab. So if I take the glass rod and I rub it with silk, it's going to become positive. So depending upon what material and what rod, the overall charge is going to be different. Remember when you did the bubbles, some may be attracted and some repelled? So again, here we see that it then loses electrons to the silk, which becomes negatively charged. Here's some other examples. A negative charge being brought close to, this is a neutral electroscope. So then it causes the leaves on the bottom to repel because all the negative charges go down here, but because it's positive at the top, because this is an overall negative rod, it causes more of the positive charges to go up here, and this is why the leaves repel. And then this is grounding, so the leaves just drop. Today, in our homework, which we're going to do problems, we're just going to be talking about this one equation. So this has to do with the electric force. So this is a force that attracts or repels charged objects. So again, if I rub something, we'll demonstrate this in a minute. So we're going to actually see the transfer of electrons. So Coulomb's law, this is F. Now remember, F stands for force. So it doesn't matter if I'm talking about gravitational force, if I'm talking about frictional force, normal force. A force is a force, and a force is always measured in the same unit, which is a Newton. So F is equal to K, Q1, Q2 over R squared. Now, doesn't this equation look a little familiar, like something else? Does this look similar to the equation for gravitational force? F is equal to big G, M1, M2 over R squared. Don't they look similar? So we see that in physics, the same laws of nature that hold true for gravitational forces in a large or small, because remember, gravitational force can exist between 2 stars, or it can actually exist between a proton and neutron in an atom. So the electrostatic force, this is called the electrostatic force, is equal to K, this is a constant, Q1, Q2 over R squared. So Q is the charge, so if I had the force between 2 electrons, this would be the charge of each electron. This would be the distance between them, and this is our constant. So remember, the thing about this is, remember, force is a vector quantity. It has both magnitude and direction. So if this is positive and this is negative, the force is going to be negative. If this is positive and positive, a positive times a positive is a positive, so the force is positive. If this is negative and negative, a negative times a negative is a negative, and the overall charge will be positive. So a negative force would mean I had 2 different charges. That means it's a force of attraction, because the only way I'm going to get a negative force is if I have a positive and a negative. A positive force means that the charges are the same, and they're going to repel one another, because negative and negative repel one another. Positive and positive repel one another. So a positive force means a force of repulsion. Okay? Now this is our example from the textbook, and what we're going to do, I'm going to work one with you. So these are 2 examples from the textbook where we're just rearranging. Now, as far as the constant K, instead of 8.99, we're going to do 9 times 10 to the 9. Newton meter squared per Coulomb squared. So we're not going to put in our calculator 8.99. We don't need to do that. And that's it.